Turning
So
or twisting movement
torque
of an axis.
twisting moment about an x-axis.
Yes, yes. Turning or twisting moment of
About an axis.
about an axis is torque. Good. You see, for a generator means synchronous machine, alternator. For a generator, mechanical torque is greater than electrical torque. And for a motor, mechanical torque is less than electrical torque. Okay, because we get the mechanical torque for a generator from the prime mover, which rotates the generator, rotor. You know, a synchronous machine, generator, or any motor has two parts. One is stator and another is rotor.
Rotor.
The stator is fixed and the rotor rotates. The rotor rotates. We always rotate the rotor at a fixed or constant speed, known as synchronous speed, so that we get the frequency constant, always 50 hertz. Understand? We always keep the speed of the machine at a constant or synchronous speed, so that we can get a constant frequency 50 hertz at all times. You see,
Sir, the board was not clear to us, sir.
Hello, sir.
স্যার লিখতেছে ভাই, এখন শুনবো না, সামনে এলে শুনতে পারে।
hello.
Sir, board was not clear to us, sir.
Board is
Sir, little bit zoom in your camera, sir.
okay. Okay, you can see now.
So can you move it a little downward?
No, sir, it's okay, sir.
It's okay, sir.
F equal to, what do you know from the basic course?
F is equal to Pn by 120.
120. Ns is the synchronous speed. So synchronous speed Ns equal to 120 F divided by P. Now P equal to, let us say P equal to 4. F equal to 50 hertz. Then what will be synchronous speed?
Sir, 1500.
1500 RPM.
Yes, sir.
RPM means?
Sir, rotation per minute.
No,
revolution per minute.
Revolution per minute.
Revolution per minute.
So that is the synchronous speed.
Sir, there is a sir two directions. One is TM direction and TE direction. Sir,
Yes.
sir, what do you mean by direction?
Or direction means when we gives a rotation to the rotor of the generator, that is TM. TM is the mechanical torque given by the prime mover,
So, sir,
engine or turbine.
the TM work in anti-clockwise.
Yeah, yes, TM in the anti-clockwise direction. It is rotating the machine.
That means the
But
mechanical torque work anti-clockwise and electrical torque work clockwise.
yes. But the thing is, if you suppose the mechanical torque you are giving in the anti-clockwise, then electrical torque will be clockwise. It means that the two torques are in opposite direction.
Yes, sir. Yes.
The two torques are opposite direction. It indicates that. Understand?
Yes,
Yeah,
sir.
you are taking power from the machine. When you are taking power, that power, electrical power is opposite to mechanical power.
Yes, sir.
আমরা একটা মেশিন টুতে করছিলাম স্লিপ বের করার ক্ষেত্রে।
Electrical power is always in opposition to the mechanical power. If it was not in opposition, then Newton's first law will not apply. If both torque work together, suppose there is no friction, then what Newton's first law says? If there is no friction,
Sir, I have another question, sir.
yes.
Sir, why we need in power system in stability, মানে stability condition?
Oh, I am going there.
Okay, sir.
Right, your question is very nice question.
Sir,
I am going there.
it's TM greater than TE and another for motor TM less than TE. So what does it mean, sir, actually?
Oh, yeah, in motor, the T we get from the electric power supply. Then we get mechanical. In your fan, which is rotating on your head, you are giving electric supply. That is, you are giving electrical torque. Then you are getting mechanical supply. That is rotation.
That is why electrical torque is greater than mechanical
Yes,
torque
yes,
for
yes,
fan.
for fan, right? Because if it would be not greater, then it was impossible to rotate it. Understand?
Yes, sir. Yes, sir.
If the electrical torque is not greater in motor, then how can it rotate it? It will not rotate. And in generator, if the mechanical torque, that is prime mover torque, is not greater, how can it rotate the rotor for electrical torque?
Sir, is it possible to express it mathematically?
Yes, we are going to apply it mathematically, which is called swing equation.
Okay, sir.
We are going to apply. So now the thing is that our desire is that constant RPM, for example, 1500, we always desire, we always want our speed should be 1500 for a 4-pole machine. For a 2-pole machine, what will be the speed?
Yeah,
Equal to
3000.
3000, good. For a 2-pole machine, the denominator will be 2. That is 60 into 50, 30, 300, 3000s. So 3000s. If the pole increases, the speed will increase or decrease?
Decrease, sir.
Speed will decrease.
Decrease, sir. Decrease.
In Bangladesh, what will be the speed of the natural speed of the motor? What will be the natural speed?
3000. 3000.
Yes, right. Good. Now with gear mechanism, you can 1:10 or 1:50. In that way, you can control it in many thousand rotation by gear mechanism. But natural speed is 3000 is the maximum. Now, if that speed, if the two torques, they are not related, then the speed will up down. Understand? Suppose 1500 RPM is there. If you load of the machine is decreased, then speed will up. If the load is increased, speed will up. If the load is decreased, speed will down. That is, the speed depends on the torque. If for generator, the speed depends on the electrical torque. If the load is increased, then the speed of the machine will what? Increase. Suppose the load of a truck or bus is increased, then its speed will decrease. Suppose a 5-ton bus, 5-ton truck, you are giving 8 ton. What will be the speed? Speed will decrease. Similarly, in the generator, when we are taking much load means electrical load, then the speed of the generator will decrease. If the speed decrease, then synchronism will be lost. That is a stability problem will be there. Now, what is the stability? Stability means, suppose that generator, 4-pole generator, it rotates as 1500 RPM. It's okay. Now we have increased the load or decreased the load. Then 1500 will not remain. It will up or down. It may 1600, it may 1400, like that. If 1500 is there, then frequency will vary. That is undesirable. And to vary the load, it is called disturbance. So disturbance means variation of load. Some short circuit fault is there, if some open circuit fault is there, if short circuit, open circuit fault, or any changes of load occurs in the machine, then the synchronous speed will not be maintained. Then 50 hertz frequency also not be maintained. In that case, we say that the machine has under stability problem. Understand? What is the stability problem?
Yes, sir. Yes, sir.
If there is
Sir,
short circuit,
if sir frequency not remain same, then what will be happened in general?
sorry,
Sir, if frequency not remain same, that means 50 hertz. If it is increase or decrease, then what will be happen in generator, sir?
good. I have done a problem in my electromagnetic field.
Yes, sir.
That is core loss and copper loss.
Yes, sir.
That is, if the frequency is related with inductive reactance of the circuit, XL equal to twice by FL. So if frequency increases, XL will increase.
Yes, sir. Yes,
If
sir.
XL is
Yes,
increased,
Okay, sir.
it will increase.
I understood,
Then current will also increase, decrease, like that. Power loss, power, everything will be, depends on frequency.
Yes, sir.
Understand?
Yes, sir. Yes, sir.
So we always try to maintain frequency 50 hertz. That is constant frequency and constant speed of the machine. But unfortunately, the speed does not remain constant due to the variation of load and fault. Understand? Due to
Yes.
fault. If there is a short circuit fault, then current will increase.
Yes, sir.
The speed of the machine will decrease or increase, something will occur. For short circuit fault, open circuit fault, ground fault, if there is fault, the speed will not remain constant. It will vary. Speed will change. So what is the stability? But we will have some device. If the speed
Comment.
vary, that is called power system controller.
Yes.
In every generator, there is power system controller. When there is a fault for a small time, the speed, there is some speed problem and frequency problem, but within few seconds, the controller will bring the machine to the previous condition. Understand?
Yes, sir.
I am just giving you some idea. Every people who are normal people, there is a controller given by Almighty. Everybody. Suppose you are getting very angry, but after within a second or minute, you are going to the previous condition because there is a controller inside your body
Sir.
that controls your conduct. You may angry, but after some time you are becoming previous condition because there is a controller inside your body that will bring you to the previous condition. Understand?
Yes, sir.
Similarly, with generator, there is a controller. That controller brings the machine to the previous condition after suffering a disturbance. That is called stability. What is stability? Stability is that property of a power system that comes back to the previous condition after suffering a disturbance or
Sir,
fault.
sir again, sir.
Oh, stability is that property of a power system. Stability is that property of a power system due to which the power system come back to the previous condition after suffering a disturbance.
Yes, sir.
Sir, it
Suppose,
will be
I got it.
it will be come back it accurate previous position or near the accurate previous position, sir.
after suffering a disturbance. Suppose I have been caught by a fever. It is a disturbance. Fever is a disturbance.
Yes, sir.
Understand? তাহলে after 3 days I am coming back to the healthy condition.
Yes,
So
sir.
it
Yes,
is
sir.
stability. It is a stability. You are coming back to the previous condition. Suppose I have become angry. Okay.
Yes, sir.
After a few minutes or after a few seconds, I am becoming again to the previous condition. Then it is a stability. Stability means come back to the stable or previous condition.
Yes,
Have
sir.
you understood?
Yes, sir.
But if I am a mad, then I cannot come to previous condition.
Yes, sir.
Huh?
Yes, sir.
If my controller is not working, there is a controller inside my body that will bring back to the previous condition. So what is power system stability? Shall I write or not need to write?
স্যার একটু লিখে দে
স্যার লিখলে ভালো হয় স্যার।
এত বড় ডেফিনেশন ভাই।
এখন কি মনে হইতেছে যে না লিখতে বললে ভালো হইতো?
You see, stability is that property of a power system due to which the system comes back to the previous condition after suffering a disturbance. Here disturbance means you see what is disturbance? Disturbance means load variations. Load variations. When you are switching on or off to the power system, it is a disturbance to the system. But people will do that because they need it. Parameter changes. Parameter changes means the reactance, the different types of reactance. XD means direct axis reactance, quadrature axis reactance, different types of parameters that can be changed, and those are disturbance. Different types of faults. Faults means short circuit fault, open circuit fault, ground fault. All those faults are also disturbance. Have you understood disturbance? Clear?
Yes, sir. Yes, sir.
Okay. Now, stability is a very desirable thing because electric power system is a large dynamical system. It needed, it needs always to be stable for proper working. An electric power system behaves essentially as a set of coupled oscillators, which are continuously perturbed due to load variations. We always require the power system to be stable at all times. It is a desirable thing. If stability is not kept, the power system will destruction. That is, it will break down.
Yes, sir.
And thousands of crores of money will go within a few minutes, with a few seconds. So proper power system stability knowledge is required for the engineer to keep their power system stable at all times. There are three types of stability we found: dynamic stability, steady state stability, transient stability. Those chapters are very nicely written in Stevenson's book, chapter 14. You go through that chapter very with comprehensive knowledge he has written. You just go through it and you will have a complete picture. Now you see dynamic stability. Dynamic stability, if there is a small variation of load, a small variation, understand? Sometimes people are switching on their load, switching off, switching on. Sometimes a small parameter is changed, which is related to dynamic stability. Suppose I am here, somebody is teasing me. It is dynamic stability case. Understand? A small disturbance. Dynamic stability deals with a small disturbance. Small disturbance. That is a small load change, a small fault that is related to dynamic stability. And dynamic stability problem can be represented by differential equation. Steady state stability, if small load changes for a longer time, the disturbance is there. Understand? those type of disturbance is steady state stability problem. And third one is transient stability. Transient stability is the study of your subject in your course, transient stability. But dynamic stability and steady state stability, these are not incorporated in our course.
Sir,
Only transient.
steady state stability sir আবার একটু রিপিট করবেন
Oh, আচ্ছা আমি বলতেছি, I am just telling you. Dynamic stability and steady state stability, the difference you see. Dynamic stability is small disturbance for a small time. Understand? Small disturbance for small time. That is the case of dynamic stability, and that can be represented by differential equation. Dynamic stability. But steady state stability, it is also case of a small disturbance, but it persists for longer time. That problem. Understand? Suppose I have a fever for 3 days. It is dynamic stability. But I have a fever for 1 month. It is steady state stability. Have you understood?
yes sir
Steady state stability is for longer period, a small disturbance for longer period. But transient stability, it is a very, very big stability problem. Transient stability problem is a big stability problem. It is due to fault, short circuit fault, open circuit ground fault. That type of fault is the case of transient stability problem. I think you have been clearly understood. If I
Yes, sir.
tell, understand?
Yes, sir.
I know you people understand very well, but you have to study the books. Otherwise, that cannot be remembered. Understand?
Yes, sir.
Yes, sir.
We have to study the books. Self study is the best study. I have just given you some idea. Dynamic stability, steady state, transient. In any circumstances, anybody can ask you, what is dynamic stability? What is a steady state? What is transient stability? So now disturbance you have understood, but in power system there is controller, because in power system very often and always there is disturbance. We are the agent who are doing disturbance to the power system every time. Such as we are switching on, switching off. Those are also disturbance.
Yes, sir.
If you switch on, then there is some power load is going to the circuit. But people will do that. Now the thing that dynamic stability, steady state transient stability is the fault case, and our study is transient stability. That transient stability, that dynamic behavior of the generator or alternator can be studied by swing equation. Now we are going to study the swing equation. The swing equation gives us an idea about the dynamic behavior of oscillation of the generator, how it oscillates. Do you know oscillation?
Yes, sir.
Oscillation of a pendulum in the clock. In the wall clock, there is a pendulum which oscillates. Oscillation. So the power system, when there is a disturbance, the generator oscillates. Now I am telling you a very important thing for your learning. The thing is that in a power system generator, big generator, not a small generator, big generator, suppose 60 MVA, 100 MVA, 150 MVA, big generators are there. I am talking about the big generators in power system. Those generators, we always telling that there are two types of winding in the power system. One is a stator, another is what? Rotor.
Rotor.
How many types of parts of the generator? One is
Sir,
Rotor,
stator but
rotor or stator.
Good. But that thing you see, you also in the machine you have learned rotor are of two types. One is cylindrical rotor, another is projected rotor. Rotors are how many types? Two types. One is non-salient pole and
yes,
another
sir.
is salient pole.
Is salient pole.
Salient pole means it is cylindrical. In the non-cylindrical, salient pole. Whatever may be the, you also know that the cylindrical rotor, what I have drawn, it is used for high-speed machine, high-speed turbines. But for a small speed, projected or non-salient pole are used. Those are the machine things. I am not discussing those. Now you see that there is, when there is a disturbance, at first the machine gives a very heavy swing, heavy oscillation. Understand? When the machine is synchronous condition at constant speed, it is a very, very healthy mood. But when there is a disturbance, large disturbance, suppose a fault, due to that fault, the machine swings very much. Understand, very much in Bengali, I want to tell you, মানে ভীষণ ভাবে মেশিন দোলন দিতে শুরু করে তখন। দোলন বুঝতে পারছো কি? অসিলেশন। When there is a fault or disturbance, the rotor gives heavy swing. In that case, the prime mover which is rotating the rotor, it may break down. Understand? So the alternator should be, high oscillation should be prevented or suppressed. For suppression of the high oscillation, there is damper winding in the machine. Third type of winding, damper winding. So in a large alternator, how many types of parts are there? Three type of parts. One is rotor, another is a stator, another is damper winding. Damper. Have you understood? Boro machine, in big machine, there are three parts of the machine. One is a stator, rotor, and another is what? Another damper. That damper, high oscillation, suppressed by the damper winding. Now we are going to the swing equation. Any question? Any question on stability?
No, sir.
Okay. Now we are going to the swing equation. Now we want to establish the swing equation. Before establishing the swing equation, I am just with some quantities. You see that I have written something. Here, delta. Delta is the rotor angle or torque angle. I have drawn a north pole and a south pole. You see the reference axis and delta angle. Here, theta. Theta equal to omega t plus delta. I have given some idea. I have written theta m equal to omega t plus delta. What is omega? Omega is the angular velocity reference axis. Reference axis and rotating magnetic field and rotor field. Rotating magnetic field and rotor field. There are three fields you see. One is rotor field, another is rotating magnetic field, and another is reference axis. The three things are rotating in synchronous condition. But when there is a disturbance, then delta and all angle varies. Delta angle varies. But omega is the angular velocity. It is a constant thing. Omega angular velocity is constant. It is twice pi f, fixed by the frequency. You can write it. Omega equal to angular velocity equal to theta by t equal to twice pi f equal to constant. So the total angle theta m means mechanical angle equal to omega t plus delta. Now we can differentiate theta m. Can you hear me? Hello?
Yes, yes, sir.
Yes, sir.
I am
First you said delta is rotor angle.
sorry.
Sir, first you said delta is rotor angle.
Yes, delta is rotor angle or torque angle, same thing.
Okay.
Yeah, rotor angle and torque angle is the same word. Understand? You may call it torque angle or rotor angle because the angle is at the rotor. You see North Pole and South Pole in synchronous condition. In synchronous condition means when at constant speed, the rotor pole and stator poles are magnetically engaged or magnetically locked. The rotor pole and stator pole are magnetically locked across the air gap at a certain air gap. একটু দূরে থেকে তারা ম্যাগনেটিক্যালি লক হয়, হয়ে they both rotates at synchronous speed in that way. They rotates in that way. But when a disturbance is there, that magnetic locking is disturbed, and if the disturbance is
Remember
too
more.
large, then
Our
magnetic locking is
educators are cheerful
breakdown,
and friendly,
broken
and
down,
your kids will
and
experience
synchronism
a
is
jovial
lost. The machine becomes breakdown. So before breakdown occurs, it is necessary to bring the machine at synchronism. The power system controller does the job. It may be proportional integral PID controller, PID, proportional integral derivative controller, PI controller, adaptive controller, self-tuning controller, model reference adaptive controller, neuro-fuzzy controller. There are many types of controller has been established by many types of researchers. And those controller work job is to bring the machine at synchronism after suffering a disturbance.
Sir,
Yes,
sir, what is I cos theta controller, sir?
sorry.
Sir, I cos theta controller. I hear this name. What is the mean? I cos theta controller.
Oh, I cos theta is the active components of the current. I cos theta.
So there was a controller name I
Yes,
cos
yes,
theta controller.
yes. There are many types of control. I cos theta is the active controller or active current controller. It only controls the I cos theta component of the current, and I sin theta is the reactive components of current.
Yes, sir.
So we are establishing the stability is a very interesting subject. Many people are doing their how to control the generator. If we cannot control the generator, the stability is not confirmed. So we are now establishing the swing equation. It is a very large subject. You have some idea. 3 types of stability. Now, the subject is very interesting. I have written theta m equal to omega t plus delta. Reference axis, it is rotating at a constant speed. Reference means just like in the per unit system, take a base. Understand? We take a base in per unit system or percentage system like that. So reference axis is the on which we are writing that. So it will be again. Omega is constant. So omega is constant. If you differentiate a constant, it will come 0. So second derivative is coming like that. D square theta m dt square equal to d square delta by dt square. We are getting that equation. Now you see that we are doing another thing. Now when we want to convert it into torque, we want to convert it into torque problem. Understand?
ইকুয়েশনটা কি করলেন বুঝলাম না, ইকুয়েশনটাতে কি করলেন বুঝলাম না, আরেকবার যদি বলতেন।
the equation is theta m equal to omega t plus delta. That is torque
Yes, sir.
angle and natural angular velocity omega t.
Yes, sir.
Omega t is a angle because angular velocity is multiplied by time.
Yes, sir.
So omega t is a angle. So those two angle, when added, it gives the mechanical theta total angle. Understand?
Yes,
In
sir.
that three things you see, in the three things,
মিজান
see that
হ্যাঁ ভাই।
থিটা m
yeah,
ইজ ইকুয়াল টু ওমেগা টি প্লাস ওটা খালি ডিফারেন্সিয়েট করছে
হ্যাঁ বুঝতে পারছি, এখন বুঝতে পারছি, কিন্তু এখানে ভাই এটা কি স্যার যে লিখলো যে এটা আপনার মানে থিটার ওমেগা এটা কি কনস্ট্যান্ট না?
ওমেগা টি
টি
কনস্ট্যান্ট।
কনস্ট্যান্ট।
হ্যাঁ ঠিক আছে, বুঝতে পারছি স্যার, বুঝতে পারছি।
তাহলে ওমেগা কে যদি আমি ডিফারেন্সিয়েট করি, if I differentiate omega, then it will come to what? It will 0.
ইয়েস স্যার। আবার সেকেন্ড টাইম করছেন স্যার, বুঝতে পারছি স্যার এবার।
Yes.
স্যার এটা কি লিখছেন, স্টান্ট নাকি?
Which things? You could give, I have given 0 together, but in the next time you could give 0. If for clarity you can give. That is omega t when you differentiate dt by dt, remaining omega, last time 0, that term is not there. So I have not written it. We finally getting what? We are getting this finally. Understand?
Yes, sir.
I had written 0. I skip it at first. We are getting those things.
Yes, sir.
That is, it shows that with the total angle theta, mechanical angle theta, the delta has a relation. It shows that. That is, delta has no relation with omega. When the machine is rotating, that is, d square means it is velocity or acceleration. You tell me?
Acceleration.
Acceleration has second derivative. Second derivative is acceleration. First derivative is velocity. Good.
Sir.
Thank you very much. Yes. That is, when the machine is accelerating, then there is no relation with
omega t.
Omega t. Good. Yeah, thank you. Thank you. It is quite imaginary. কল্পনা করা হচ্ছে. We are imagining reference axis. We have taken, we just imagine a reference axis, and you think that the reference axis is rotating, and with it, I am also rotating. Sometimes my speed may come smaller, greater, in that way, variation may be there. But the reference axis velocity will not be changed. Now you see, we want to go to the torque equation. What can we do now to go to the torque? If we multiply that equation, if we can write, we can convert it into torque equation. How can we write it into torque equation? We want to convert it into torque. Understand? Because at first I had written the torque equation T, TE and TM. Understood? T and TM is there. So we want to do a thing. Now I am writing. From the equation of synchronous machine, from the machine subject, we know that J t square delta by dt square equal to Ta equal to Tm minus T. Here J is the moment of inertia. J is the moment of inertia of the rotor mass. Rotor is considered as a mass. So J equal you understand? Here G, but in case of synchronous machine, it was delta, it was theta. In synchronous machine, delta was not there. It was theta m, mechanical angle. So now by using equation 1, we can write it using equation 1. Equation 2 can be written as you see, the electrical torque must be less than mechanical torque. Mechanical torque means torque of the prime mover, engine or turbine. And electrical torque is the torque, the power we are taking. So our taking must be less than our supply.
Yes, sir.
Understand? Then the machine will accelerate. Accelerate means.
Sir, we are considering here generator or motor.
Thank you.
Generator.
Here generator. If you consider is motor, then T will be greater.
Yes, sir.
T minus Tm. And Ti is the accelerating torque. Otherwise, the rotation will not exist.
Yes.
If Tm is not greater. Understood? And you see, from the equation of the machine equation, we have converted into swing equation. In place of theta m, we have written delta, because inside the theta m, there is omega t. But we see that omega t has no function here, omega t. So we skip it. And we have written delta in place of theta m by equation 1. Understood?
Yes, sir.
Now we want to convert it into power. Now that equation we want to convert it into, what can we do now? We will further go ahead. Now want to convert it into power. If we multiply both sides by omega, we want to multiply both sides by omega m. That is angular velocity, both sides of the machine. What will occur? You see. Multiply. You may ask me why you are multiplying, because we know that P equal to j omega. If we moment of inertia, if we multiply by omega, then we will get a power. That is power equal to j into
Omega.
yeah, right. That's fine. Omega t. Understand?
Yes, sir.
Here omega m, we have given mechanical torque, means it is the torque of the turbine, the angular velocity of the turbine, everything of the turbine or engine. Prime mover, we called prime mover, general name. Yeah. এটার পরীক্ষা কবে হবে? এটার পরীক্ষাটা হবে না। আচ্ছা, now we see that omega j equal omega m j equal to what we know, power. Omega j, that is we can write
Sir, can we have 50 minutes break, sir? Hello, sir. Sir, can we have get 50 minutes break, sir?
yes, yeah, you take 10 minutes, then we can finish. 10 minutes you can take.
Okay,
Okay.
sir. After
Sir,
10
please
minutes, 15 minute
15
break,
minutes
sir.
We
break.
will join. We will
Yeah.
join again, sir.
Oh, 15 minutes is a long time, 10 minutes. So that as far as